Well, yeah.
Yeah, she was good.
You're doing great.
Hello.
I also
Miss you too.
But yeah,
it's really
definitely progression. You know what I mean? And what you just did with Phil's show, you wouldn't have had the knowledge and experience to have done at the beginning. So
Probably
you know,
not. No. Welcome to the August 19th edition of the Electric View. I'm Neil Thompson. Today we have Heather, Edwin, Buddy, Dave, and Jake. We will be discussing the nature of science, what passes for best proof when contesting paradigms, and how citizen science and the internet are rocking the mainstream. Please like and subscribe below. This is twice now. Within a little while, all of us are sort of like...
They put the... was it Jacob? Yeah.
Yeah. And Eileen was
right
just
on. I mean,
out
he's
there.
just yesterday. It was yesterday.
Yeah. And it was just the way that they do it, and it's beneficial for, because we're not doing the same thing at all.
Yeah, it's like
Space
this whole
News, so.
crazy cross-pollination.
Exactly. And I encourage, if you guys...
videos.
But I think he mentioned EU Geology Facebook page too.
He did.
On that. So that was a good,
Shout out.
Promo.
I feel bad that I might have confused him on what inductive kick meant because I realized he said in his video, he was like, but we don't know why the dust goes flying. And I was like, I just told you just 2-3 days ago, but don't worry.
But
You're not supposed to memorize everything. You're not into that, right?
Yeah.
He did an amazing job.
Oh, God, yes. Beautiful. No
it was inspiring. That Space News was really inspiring because he's like just what I'm doing in my kitchen, and he's mentioning all these things that he's watched: Thunderbolts Project, EU this, EU that. You know what I mean? All of these things. It's like he can touch space in his own kitchen, and it's like that is so inspiring and exactly what we're trying to do here. So I really enjoyed it. I thought it was amazing. Yeah, he got a couple terms not quite right, but
But this is the problem where this locks everyone down because you get afraid of I'm going to misspeak, and then you shut down the inquiry. And this is a real problem. With academia particularly, obviously.
Oh yeah, but it's amazing how much that happens with us, even with myself. I wouldn't say I'm, obviously I'm fairly broad-minded, but I meant that you end up trying to be accurate because you think of it like it's the end of the world if you got a formula wrong or spelled something.
It's never. I mean, you learn the most from like missing the mark and then coming back around again. That's how you get the insight into stuff. Oh
yes, of course, but it's the I hate to say it, it is the relentless trolling from intellectual institutions that will.
Well, that's a golden opportunity for humor, because it's like it's just really it's golden.
Well,
It's like who do you think you are, like pontificating? What do you have a pontiff's hat on? That kind of thing. Did someone create a priest? And that's the harsh angle on it.
Well, it's. I mean, we call them the priests. We call them the priests of scientism. That's kind of like the little joke from Rupert Sheldrake when he came by. He was like sort of merging. He was like, science set free. It's like you guys are like literally saying like this is wrong. You have evidence that it's wrong, and you keep the theory anyway. And he's just basically saying, you're not doing science anymore. And this is what we're basically saying. This is why we merge very well with him. I mean, whether or not we agree 100% or disagree wholeheartedly, at least we know that his evidence is backed up by experiment. So is ours. They're not doing experiments. They're playing with numbers and dreaming of what they see and telling us what they think they see, and that's not going to help us very much.
And then making it as major declarations of the universal truths.
Yeah,
without experimental,
well, I was just watching
foundation.
something from 2014. It was Wal Thornhill was doing a talk on from the EU 2014 or 2013 or something, and he was like saying, I remember 10 years ago saying, I hope we finally broke ice now. Like, I hope we finally got enough momentum behind this thing, and now here it is now 5 years after that, and now we're starting to see, because this right here with Jacob, what are your qualifications, Jacob? I know how to make things float around in a bottle. I know how to make a vacuum pump and stuff, and I went and played around with that after watching you guys play around with it. Like,
right.
That's it. That I had an idea, I went and experimented. That pure nature of it is, and I know that Edwin had to do a lot more inferring or deductive reasoning there, trying to understand how his model worked, because inherently it's the same problem that we're having, that every electrical engineer really has to deal with, and probably every nuclear chemist as well, is that everything we play with is imaginary in our heads. Like, I don't see electricity. We see it here, but this is a rare example. Most of the time.
Well, this is where you look at it. I mean, to understand what's going on, this is how.
Yes.
You spin around this a million times, and you get a familiarity with the behavior,
But
that's how actually you understand your reality, I think, and to have it put into a type of scripture, our rationalist materialist view,
right,
is a type of shackling.
Well, I would. I keep going back right to Dr. Aaron Bond from Staten Island Community College when he was doing a little talk there in Bonds of the Past from 1972, 71, something like that. And this was all about Velikovsky, of course, but his talk when he spoke those words, and I recommend anyone just go look. He's within the first 10 minutes, and he's there for almost the entire rest of it, and he's the dean of the sciences or whatever in that community college, Staten Island Community College, and he was saying, this was back in the 70s. He said, the institutions are becoming so inflexible and so that they're interfering with the freedom and looseness to think.
Right.
And that is just the purest answer I really thought about it, because that's what's going on. They're trying to set stage, they're trying to set standards, and that's not how science is supposed to work.
Well, yeah, I mean, the one that the bellwether for me was this, with the global warming stuff. 97% of scientists agree. It's like when did science become a consensus endeavor?
Well,
ever.
Yeah, but like 100 years ago, when things had to be bullied, when people were like, when people like Bohr were like, no, I would prefer if you did it my way, and since I'm the oldest person here, we're going to do it my way, and this is going to be my model. Ta-da! That's that's how those things came about, and everyone went, I guess so. You're the smart one.
It's a religious endeavor, and this is, I mean, the extreme contradiction is that they, promote the fact that they're rationalists, but it's clearly a belief system.
Can we just look at the positive here for just a second?
Oh, come on, this is fun.
Come on, I know, but we haven't.
Grouch session.
That this is a perfect example of citizen science and the beauty of the EU community at its best.
Yes.
Allowing a citizen scientist to present his work and findings, embracing that and lifting him up to show others, like, you could do this too. This guy did this. We're not looking at his exact verbiage. Obviously, he hasn't been trained in the jargon. But what he has been trained in is inspiration and knowing that this is a community that we can approach these things and people can talk about these things, and any person who finds it in their spirit or selves or daily activity to put some of these theories to the test and say, you know what, I listened to these guys, I've been enjoying the Thunderbolt project, I've been watching these guys do this thing, that thing, and the other thing, and a lot of people talking about this stuff, and I wonder if I could just do a simple experiment to prove to myself or to actually see these things in action and then, just blow the lid off the whole thing, metaphorically, obviously, to say, this is happening. This is plasma machining. This is what's happening below the surface. This is how a cathode and an anode are interacting with each other in a vacuum with simple things. So what he did was he had a very small amount of air, right? He had earth, he had water, and then he added fire. And it was how do all of these things interact? How do these 4 states of matter, the 4 elements of the universe, interact in a plasma chamber when there's a direct current flowing? And if he could do that, what else could anyone else do?
Oh, yeah.
So it's a beautiful opportunity, and it makes me proud to be part of this community, because as of late there's been, and I guess always, but there, people have been getting aggressive, people kind of get bitey at each other, and it's go away from us. We're trying to have a constructive conversation here. You know?
Yes.
And by doing that, by saying, that's not what we're here to talk about. We're here to talk about this other thing, and allowing just anybody to show us what they're doing with an open mind, it's very encouraging, as opposed to saying, you don't have that degree, you don't know our dogma, you don't know our language, and you don't know the theories that we adhere to, so therefore your voice. Remember when we had this talk before about what makes someone qualified to share their opinion?
Yeah.
Everyone is qualified to share their opinion as long as it's considered. They considered their opinion before sharing it and thought it out, and you know what I mean? Not being mean to people, not screaming or yelling at people. I that's what this is. I'm so happy, and I was so happy to see the space news.
Yeah.
High five, everybody.
High five.
High five. Yeah. Oh, they're showing how it should be done, and I thought it was weird, when you mentioned setting standards or setting the consensus. Dave, you hit something with me when I just was thinking, wait, it's the engineers who should set the standards, because they're actually building things. Your scientists are just supposed to go here. Yeah, exactly. Scientists should just go. Here's an effect. Here's a few things that might work with this effect, type of thing. But they don't go around and say, "And this is the way it must be." I've never, when you're building something, you kind of need that, right? You need everyone to go. This is the color codes. Here's the resistor codes. Here's how you read standard. These are standards. Is what I meant was.
But I'll argue standards are a problem too. I mean, because I think you can go in, and when you create a different, for instance, the resistor codes. What was the one what's bad beer rots our young guts, but vodka goes well, huh? That as far as the
yes.
Yeah, but
all the homage and stuff.
But if you switch that up, you end up building different types of things.
Well, if I may,
standard blocks.
Go ahead.
Can I interject there? So, what Neil is saying, I more or less agree, because I think science and technology are pretty much separated. So we have a different world of science, which is totally disconnected from technology. And technology is what we see, and science kind of sort of follows what technology is able to create. And it's just a pretty story. It's just a fairy tale. And I think, not only that, I think Neil's right also in the sense that technology, so what we actually can do, driven by experimentalists and dreamers and whatnot, and thinkers, and
of course, yeah,
they are the ones that break the boundaries.
Right.
Usually.
Right.
Yes, Agreed, because a lot of this technology that we have, we don't even really understand how it works. We just understand that it does work.
Yeah, science kind of is pedaling behind it.
Yeah.
Right, but it's a limitation because of the model.
Well, actually,
yes, exactly. That's why a good
okay,
model
right on that.
is so important.
I just meant, like, for example, Jacob is using the stuff that engineers have put into codification, so to speak, and made parts for, and so to speak. But he doesn't really have to know all of that crap because of the fact that there are standards to put them together with. And he ends up doing wonderful things with it because, more or less, because he can assemble a few working pieces together. That's the wonder of this whole, what engineers kind of do, at the end of the day. But you're right. There is. I just thought it was odd, though, that you get this whole weird that a scientist would be going that this has to be this way. Like I just.
Yeah.
I'm like, why?
Well,
like, I mean,
you literally should be thinking totally freely.
If I can segue just a little bit,
segue away.
The one I'm dealing with daily. Right now, there's on Facebook, somebody's posting on my timeline, and it starts to write, the light we see in our daily lives has a hidden key, which has the power to open doors that have never been opened before. And then it goes on with a link to some kind of article or some kind of scientific paper where light is the building block of everything. And not only that, it's divine. Did you know? Did he mention that it's divine? And then it's based on quantum mechanics, mathematics. Totally strange, unreal stuff. Mathematics, not even real mathematics. And that is given credence and turned into reality. That is the state of science today. And I'm being bombarded with people that keep telling me, but everything is a wavelength. Everything is light. Everything are electrons. Everything are neutrinos. I've heard them all, and I keep seeing new ones.
Actually, I was going to say that too. I found that every time that someone, and I don't like to say this, but I don't know if Ken Wheeler's doing any favors for some people either, because they'll go in and totally absorb his metaphysical, and then I hear them regurgitate it, and I'm like, and just like you said,
but he stays away. He stays away from metaphysical, actually.
Well, yeah.
Is that the tattooed guy? Is that the guy with the tattoos?
I
kind of like him, kind of, sort of.
I don't necessarily disagree.
He's seeing some interesting things.
He does.
But he actually does stay away from metaphysical. But
I wasn't trying to jump down his throat. I wasn't trying to jump down his throat in particular. I just meant in that vein, someone will sort of absorb that, and then you see this weird theory come out of left field, like everything's always neutrinos, or there are no physical particles. Every single thing in the universe is just frequency. But the tangibility or the way that how do you work with that?
Yes.
It becomes it might provide insights, but we really don't know for sure. I can see electrons, as me and Edwin have discussed, but protons, there's something different going on there. Maybe I'm wrong. I don't know.
If we go back, this is a scientific principle I just was complaining about. If we go back to an experimentalist, he or she has nothing substantial to do with that. It's totally irrelevant, because there's still a glass wall or a steel chamber or a rubber hose or whatever, or air, pressure. They're real tangible things, right? And that's what you work with in practicality, in reality. And science has lost its way. That's kind of what I'm saying here.
Yeah,
they're totally separate.
It's our job to
introduce
a new way of looking at it. For me, the model itself is something that is basically a scaffolding to do something, right? And the model can change,
right?
Depending on what you're motivated to do or inspired or to do, right? This is the opposite pathway.
But that comes down to also like how the artist approach things. You're making it sound, because we don't know we can't do stuff and we do it anyway. So people are like, do that. We're like, but I just did, you know? And also being able to look at how things function and put them in theoretically, and then somebody who's actually had their hands on it saying, well, but it doesn't work that way, you know? And then you've got like scientists or theorists saying, like, building things like you guys are talking about as engineers, you know how things work, what doesn't work, what can't work, what put things together to make them function, because you put your hands in it and you build it. So people who are looking at, say, like these ancient monuments and things like that, and they're like, or like not even just monuments, just artifacts, and like how did this come to be? And it's like, how did they mold these things out of stone? Well, especially ancient Egypt. You look at a lot of these things and we're like, there's no way they could have made that. And it's like, well, they poured it. Well, what do you mean they poured it? Well, whatever they did, they liquefied that stone and they poured it into a cast, into a mold. And I can tell you that because I can see how a mold was built and I can see that it was poured. But it shouldn't have been able to do that. How would they have the technology to do that? What would be the way for them to do that? Well, I don't know all those things, but, you know, as an artist who's poured many materials in foundry and in metal and in clay, you know, casting, we can clearly see that's how that was handled. And we're not given that credence, or maybe even given that chance to say, and we're told that we even can, you know, to walk into the museum and see these things, and we're told that's what this is. And you're like, well, okay, because you don't know any better. Or even as an artist, you're told, oh, that's how they made it. And you're like, I don't know about that. If I was going to make this, you know what I mean? And then to be given the EU and say, look at it for whatever you see and tell us what you see, and have individuals say, well, this is what this is. I mean, that's a beautiful thing, and it's going to open a lot more doors. Because I think we underestimate ourselves, we underestimate our ancestors, and we're definitely underestimating our predecessors, or maybe let's take that one back. We're giving our predecessors, like, they'll figure it out eventually. You know what I mean?
And they'll laugh at us.
Well,
exactly.
It's the day, too, you know.
I just
separation.
Think, well, what Heather just been saying, I think I really like that. But I would argue that it's being taught to us that we cannot go outside the mainstream dogmatic thinking. And not even, just don't go there, preferably. So in my mind, and like you said, Heather, if somebody goes out of the mainstream curriculum, you're basically a pariah. You're out of there. Right? If you keep insisting, you're out of there. You lose your job and all your status and whatever. So, and everybody, we are teaching ourselves to fall in line and follow the curriculum. So we're no better shape at all than, I think, 600 years ago during the Inquisition or whenever that was. Right?
I think this is where we have a golden opportunity, and it's the same thing that happened with the printing press. And, you know, not that I'm a fan of the whole situation with Martin Luther, although it was a situation that was interestingly caused by the printing press.
Okay,
it's that science is so brittle that this structure of it's like a trial situation where you submit a paper and we're gonna decide if it's worthy of getting up, percolating up to the top. And exactly. It's like that group of judges that are there. I didn't elect them. I had nothing to do with them. Who are they to have authority over me? And look at how brittle this system is. And it's like, this is where the merry pranksters thing comes in perfectly. It's time to throw some rocks at it and see what happens. And I've found you start throwing you throw a rock in a fun way.
Why
it has
not
a major impact?
Well, the point is.
Just a second.
So, I'm sorry. Yeah.
I was just going to say, you just basically said the exact same thing that Martin Luther said.
That's what you know what he did, right? I mean,
of course I know what he did, but you just said the same thing.
Radical. Yeah, of course.
Because
it was absolutely radical.
But the end result is that with the printing press and the ability to exchange information quickly enough, the stories that are being fostered upon us became obviously incredulous. Like, there's no way you could. I mean, with Aristotle's logic, things in the Bible seem now supernatural, and that was what people were rejecting. With the with the same things happening here when people, because once we realize, and I'll let you speak in a minute there, but I'm sorry for interrupting, but once you realize that the schools of Egyptology that were first formed were formed in Great Britain, and they say right on their plaques, like in the 1880s, to reaffirm and support the biblical way of the world, or whatever. It was basically they were going to use Egyptology to reinforce Christianity. That was always what Egyptology was about, and this is why it will never ever change, because it is literally so far removed from a science, it's a religion.
Well, that's exactly my point. Whenever you are associating yourself with science, any official science, through papers, publications, talking to them, and it could also be Egyptology, the answer is already fixed or a variant of it and not too far from it, right? The answer is already known. It's already there. We cannot and shall not deviate from it. So anybody, even in the most honest attempt, and even in the strongest position, with all the evidence on earth, you will not get your hearsay. You will not be vindicated. It will be omitted because it's not the truth, and the truth is already known. So why even bother with these people? Why not set up our own system? And I know the words come across probably a bit ridiculous, but why even look at that system that's already known to be true in their way?
Yes, exactly.
Amen.
Exactly. Don't fight against the broken system. It's already broke. It's obviously flawed. Build a new
and rigged.
system.
And it's rigged too.
Yes.
They're cheating.
They're cheating.
I'm more aggressive.
Well, but then that goes for, because it's always more productive and always more substantial when you're fighting for a cause, when you're working for something, when you're working toward a goal. Because no matter what no matter what it is, where you put your energy, that's what's going to magnify and that's what's going to come at you. So if you're against something, you're going to just keep fighting and fighting.
Are you going to just but are you just going to?
It's going to keep being.
Are you going to continue to turn?
Yeah.
Are you going to continue to turn the other cheek, because you're going to get it, and it's going to come from an authority?
Well,
no. I'd rather not be there.
Well, why not diffuse the authority? And then
put it a different way. Galileo got the priests themselves, to come and look through his telescope. At the end of the day, they all agreed on what they saw. They all knew that they were looking at the four biggest moons of Jupiter. Okay, and they thought that was another solar system out there, and that just proved that we are orbiting the sun, type of thing, and this is how this thing's going to go. Now, he got them. This is the institution of the day. This is like us inviting Michael Shermer to come to the EU conference. That's what to get those people in there. But right now, I'm totally with Edwin. Ignore them all now. Yeah, but they have the authority. Because they have the publications, and they have.
You don't invite them to review. You just do what Rupert Sheldrake's doing. It's basically diffuse the entire foundation of the thing.
Right. However, I would argue that the authority they have or claim to have comes from us acknowledging and fighting with them. A priest in a church wants nothing more than a big flock that people come to the church. It's not that he expects them to believe everything or that there's no arguments, that he wants them in the church, in his flock. What I'm saying is, I'm going to stay away, and I'm going to tell everybody to stay away. Mm-hmm. Because they get there.
You don't have to fight them. You just have to point out the flaw. And there's many. He's got the great. There's 10 points are great.
Yes,
to start, and there's many more, by the way. And ultimately, you look at the fundamentals. Just go down to the fundamentals, and that's where you find them. And it's the simple ones.
Well, it's the same thing that Sheldrake, with his Science Set Free, and Wall Thornhill, for example, or Don Scott, or even Dave Talbot, just for a few minutes, sit down, or anything that I could regurgitate. I'm sure that you guys have seen the big fight that went across the Electric Universe thing when that, we'll call him a troll, but he was. He thought that he was walking into the Flat Earthers convention and he was just going to make fun. But the arguments that came from people were well thought out, well reasoned, and they were basically saying, this is what science is, and this is falsification of your thing. Like, for example, the dark matter thing. When you explain to someone how dark matter came about, you realize it's silly. It's patently absurd, and that it's the same, probably the very same thing that you look at when you see people talking about quarks. You're like, what would make you just start calling them these things? That
Rube Goldberg machines.
Actually, quarks is building blocks smaller than a proton normally, right? In a nutshell.
Yeah,
and that is something. Yeah. But the people talking about that, thinking about that, making models about that, speculating about that I can dig. I have no problems with that.
Of course,
right? But if you go talk antimatter, which comes from a minus sign in a formula, mathematics, and then we say, well, that represents matter. Well, then the other one must represent antimatter. Now I made math a real thing. Or rather, I base my reality on the math. This is what quantum mechanics does.
And what black holes do.
And all the people in quantum mechanics say then, yes, but, which is a weak offer of weakness, yes, but, da-da-da-da-da-da-da-da. No, there is no yes, but. You made a mathematical formula with a minus sign, a physical reality, and now you want me to listen to all that stuff you have to say about that model, how beautiful it is, how difficult it is, what enigmas are there, what research we have to do, according to that model. It's not even a model. It's a reality based on mathematics. I'm not going there anymore. And I will point it out to everybody that does quantum mechanics. Now, is everything wrong? No. Not everything is wrong.
Of course.
But the fundamentals
I have a
quantum
question.
Mechanics are wrong. Sorry, go.
Yeah, I have a question on this because this is a let's say a paradoxical kind of thing. But if you look at like what we're able to do and kind of like the stuff that I'm involved with, but you can start visualizing things that aren't real. And one of the foundational ones that we know, and there's different arguments of what the reality of them are, but imaginary numbers and complex numbers, and then you start looking at recursivenesses, and Buddy's very aware of this as well. that form out of it, that can create just amazing visualizations of a behavior of mathematics over like large swatches of data sets, and then you can and the experience of seeing that thing is a type of reality. It's not physical reality, but it's a type of reality that I find really interesting.
This is something different, right? This is a whole different thing.
Well,
why?
It changes
because it's wrong.
Important. Well, it changes your world.
Wrong.
Yes, 100% friggin' wrong. And I'm not trying to.
Because that's really declarative.
Yes, and I'm sorry for interrupting you, buddy.
Hang on,
watch out because
the part is wrong.
This is
no. What Edwin is referring to, not anything that you're doing, buddy, or anything that you're. I think that you're missing his point. He's referring to the reification of information which is not real. It's never been proved real,
right?
And they're bringing it into reality.
What's real?
Yes, they created their own reality based on a mathematical model, if you will. And what Buddy is doing is visualizing using math and pointing out
that's different. Something.
Yeah,
but that's
totally
why? Why is it different?
Because one of them is okay.
You're saying material.
Let me give you a very simple
difference between them, and Jake can probably clarify about this because we're both deeply immersed in the science and the math and the application of these different geometries. Now, math, there is a lot of wiggle room that they try to construct for constants and to try to verify and to alleviate certain constants or to fudge our numbers for our forces to work for them. But when you have a geometric model that describes how things emerge out of this this reality that we perceive, that we also sense, that we also measure, is logarithmic and repetitive and it recurs. It's a recursion of a fixed now. It's a recursion of all of the information in the universe, and then it coming into existence in the next moment. So it's a repetitive, cyclical, fractal, and it's very electrical and alive. I mean, but
so
the best math that you can design is geometric in nature, because once you have the geometry to it,
you have no argument there.
Is solid, and there is no falsification, no matter what.
Right.
When you have the geometric description of either a form or reality or constant, but when you have a model that works with all of them, involving what Buckminster Fuller referred to as the isotropic vector matrix, and then you have other types of reoccurring wave cubic field type of boundary systems, then you start to see, and you can visualize these deeper sandwiches, or what they're actually called is nested hierarchies. They're nested inside of each other. Rupert Sheldrake talks about this, and this is how the actual fields of emergence come out of the echoic chambers of crystalline fibers, which is perpetuation. There is progression to this geometry, and there is change, which allows for change, and there is projection. All things are being projected outward and inward. So this is a living, breathing, implosive, explosive reality that is being described, and it's not only being described by Terence's wave conjugation models, Terence Howard, and also the Doherty set, the Doherty network, and there's many different types of ways of going about this, like the E8 type of geometry for describing mathematical models.
Too much info. Let me respond to that first part there, please, because I feel like I have to defend mathematics, use of mathematics. I have used mathematics myself a lot, right? I'm not poo-pooing mathematics.
Obviously.
What Neil very nicely put together there is, I don't poo-poo mathematics. What I have a problem with is when I put a minus sign on one side of the equation mark and say the other side with the plus is matter, and then therefore the other is antimatter, therefore antimatter is a realistic thing. Now I have a real problem with that.
What you're explaining, it's the declarativeness of this is the truth and the only truth, and this is the problem.
Not just that.
You're arguing a different problem altogether. Like
right,
and no, I have to be clear, guys. It has nothing to do with taking something like like a set of mathematics and trying to ascribe this to reality to see if you can actually find ways that this could be helpful in predicting nature.
That's just a tool. It's just a tool to find out something, and it's a very thin line.
Wrong.
Please.
Well, hang on. Let me
Neil, I have to make one request. When you make a statement like that, that can be cause a very strong reaction. Okay?
Yeah, it should.
Because you're making shall we get the octagon out and go for it?
What are you talking about?
Wrong. Not even wrong. And it's like this is just very strong, and it's actually rude. So
all right. Yeah,
I still haven't even finished my statement here. Like
start with a statement like that.
You have to, because it's
you don't.
Yes.
Talk about grace and talk about courtesy.
This is nothing to do. I don't know why either one of you are taking it remotely personally. It has something to do with exactly what Edwin was talking about. Yes.
Hey, Neil, you're wrong.
That's fine, but it has nothing to do with. No, you're missing the whole point. The whole thing. He is talking about the reification of something that is fictional or otherwise ascribed only to mathematics, and then putting it into reality. It's the same thing as when someone says, for example, that the magnetic lines of force are breaking and reconnecting, this magnetic reconnection. There are no magnetic lines of force. They cannot break.
It's a model.
But that's the point.
And that's also semantic.
That's not semantic.
No. Whether the model is real
semantics.
or not doesn't matter. It's whether it's useful. And it's like the realness and the declaration of it is incidental to whether it's useful.
It's not the point. I'm with Neil.
All right, well, I'll stand alone.
No. What you're saying, your argument is a valid one, David. But that's what Neil and I are saying is that's not what we're saying. We're saying something different.
Tell me.
A model that's all good. That's where you're coming from. We accept that. We agree on that. But if you're gonna go, I have a fantasy, whatever I base it on, and I claim that model is more realistic than the reality that you can perceive in any way, shape, or form, which is exactly what quantum mechanics does. That is a problem.
I agree. We're totally in good concert.
I don't agree. I think that if there's something that can be greater than your perception, it doesn't mean that it can't happen or that it's too good to be true.
How can you understand something greater than your own perception?
It's always going to be a subset.
It happens all the time. It happens all the time. When you walk down the road and you look at a pine cone, you're going to tell me you perceive all of that? No, a pine cone has so much information inside.
No. That is something that I can perceive. You started off with saying that something is greater than our perception. So how can I even understand something that is greater than me? It's impossible.
If you look at a shell and you study the shell your whole life, you will always learn more about the shell.
So that falls within the limits.
All things have more descriptive nature than any of us can possibly even fathom. And none of us are even close to describing even what water is. Because there's how many types of water are there?
No, you're describing learning. That's not without the limits of my perception. That's within the limits of my perception, and I need to learn to expand. You're describing learning. You're confusing things.
I think, though, that it's not really a matter of trying to think that there's not use, like I said, in seeing something like you're doing and trying to infer or see patterns and to see recognition and to see where this leads. That's good. That's something us going around and saying, imagine if there was something called antimatter, and because of the negative sign here, could you imagine if that was real? And we had a wonderful conversation about it. That is totally different than declaring it real by some sort of official board and making it so. One of the things that
the official board is the thing I have the trouble with.
Well, fair enough.
It's like imagine. I mean, I like imagining antimatter and then playing, but to state that it's the be all end all is where the problem is.
Well, and that's exactly what he's saying. And one of the things that I found is for example, a perfect example is when you build a ideal version of a schematic, for example, a Tesla coil. Now, if you build it the way that it looks like it's supposed to be, you realize that the voltage going to come out of this thing when you go back and forth across the whole, the whole kit and caboodle is according to paper is going to be billions of volts, billions, but it will never really get there. There are other things, other parasitic issues, other things like
billions,
that.
It's a scale.
Well, but what I meant is that reality has a way of showing you that you're not correct, and there's more to it than that. Because we try to work with the data and try to make it into reality, but we see the limitations of the things that we're working with. In this particular case, what they're doing with that model that here mentioned here, or with dark matter, or with these magnetic lines of force, there are no magnetic. The only magnetic lines exist on paper. They don't exist in real life. When we see the lines in, say, a fluid, like, for example, Ken Wheeler, we're seeing the alignment of particles in that fluid. And they, of course, contract their own magnetic field and make their own lines. but that's not really the lines that are there. The whole field is a
geometry.
continuum.
There's a geometry,
and it's beautiful.
It's reflecting,
of course,
but it's reflecting. And this is where there's a spectral nature to all of this, and it's like this right, this wrong, or correct is polarizing, and it's like it's your own. You can only get glimpses of things, and it's very nice to have a spectral view of things versus this hard,
I like that.
Right and wrong.
Well,
right.
Yeah, but and
it has to be available. It has to be available for change. Even
of course, it's available for change.
Scientists and mathematicians. I mean, we can't get down on them too much. They celebrate when they're wrong because it's better than them thinking that they were right, because then there's more mystery for us to go and search for.
You learn the most when something doesn't work than when it works.
Right.
You're trying to make something work, and when it doesn't work, you learn like 90% more than when you get it to work immediately.
Yeah.
But ideally, scientists are excited when they prove themselves wrong. But that isn't really how humans feel
right
when they aren't right. So, we have to always consider, and what we always leave out of science is the humanity. And the fact that all of these people are humans, and they're subject to everything that makes them human.
And we think that they're higher than that. A lot of us put them on pedestals that they don't deserve. They're just like being you in many ways.
Or to think that the fact that they study science somehow removes them from their natural human reactions and behaviors.
Which it doesn't.
It's a virtue of seeking the truth. You're seeking truth.
Adopting to scientific rigor means idealistically, right, Heather? Ideally, that you are above human emotions and your personal opinion, etc., etc. Mm-hmm. If you do not, you will find that it will influence your work and you will go awry. Mm-hmm. I deal with that myself in my own model, working with the model, because I cannot afford my own opinion to overrule anything that I observe, right? Or which I would like the electrons to be a particle, preferably, because that would suit my model so nicely.
Right.
And that is what many in the end do. That make that error that is, right? That kind of error. And I cannot say I don't make them myself, but I do try to correct them, right? And about the way at the beginning of the talk, Neil, you mentioned something about me and my model, and having to work with my imagination, right? And you were spot on there. Yeah. Yes, in many ways. However, I do use the math, or rather the numbers, if you will, simple arithmetics.
Certainly, of course.
So if I look at the numbers of the elements, meaning the atomic mass number, how many nucleons it has, right? So oxygen has 16, neon has 20. What makes it work? Why is the periodic table in the periodicity and in the groups that it has? That's one of the things that is arithmetics, if you will, pattern recognition. That is one of the
a whole different ballgame.
Right, and that's a key thing that I've used, but I will never say that number represents something physically real, right?
Well, I think a lot of times things like that periodic table gave us the impression that, for example, we made elements that didn't exist before, and that we also looked for elements that should be there because this table said so. And this is a way of basically something like laying down the Doherty set across something and going, I see where this could lead. We should see something over here. Aha, let's go investigate and see if we are correct. Well, wow, it is that we've noticed a pattern. This is good. We're seeing this, how this could pertain to nature. We could learn something through this. That's a whole different ballgame than like we were talking with someone who is really educated or should be, and they go and say things that are common mistakes that end up for example, the same thing that caused me, like when I spoke to Edwin's, and he told me about how atoms really work and how electrons are hovering over a certain area, and if they're 98% in this area, and I was like, whoa, that's totally not what I learned when I was in school. I learned the Bohr model, and here it is right here. And then, he's almost laughing because he would go, wrong. It doesn't work that way. That's just a total misconception now.
And I'm not saying there I know the truth, right?
Well, no, but you're up on the current, is what I meant.
No. I don't know what an electron is. I do not know what a proton is. I have a hunch and a suspicion on which direction it goes. That's something different, because I have some fundament for that, meaning a structural thing, and I can learn from that. Just I learned from the numbers to figure out the how the elements are shaped in the geometry, right?
Right.
If now we have that, we can look further and try to figure out exactly how they are connected and in what way and how that functions and works. There is a lot of data there. So mathematics and arithmetics, all that stuff is very much there.
Edwin, did you end up meeting up with Terrence at all?
No, I never got a response, I think.
Oh, because I remember you guys were going to meet up.
I did leave a message somewhere, but it became silent there. So
he doesn't. Everything's been in process,
and I haven't
on email. He does text, so I don't know if you got his phone number or not, but I can hook you up with that so you can like move forward if you were coming out back to the States again.
Well, I'm not sure yet. That totally depends. And the first occasion that comes to my mind would be May next year or so. Yeah.
Okay. Nice. Cool. All right. Just trying to stay connected with everyone because I know that your model describes so much about the model that I'm involved in and discovered, and then it involves so much in what Terrence is doing and Walter Russell. So ultimately, what we're all kind of trying to do is describe, and I feel like this group is very fundamental in this and progressive, the nature of light and reality. And, there's a lot of different fun topics that we cover. But like near-death experiences could be a good idea or tunnel for us to delve down sometime. But
well, I never thought about that.
I'd rather stay away from that if I, at least
there's a lot of fun areas to touch in that for sure.
But I can see exactly the thing that you were mentioning there about God, I lost it. I had it. I lost it. It was
maybe we should have started
Spirals and Scrolls.
With Spirals and Scrolls. Yeah. Well,
how just jump on something.
No, I was.
But I think about Spirals and Scrolls.
How about Birkeland currents and ancient scriptures?
Actually,
I think
I remember. We could talk about that actually, and I really don't have a problem. But I just remembered my issue was the way that when they have a thing that you had mentioned, for example, when the ego of a scientist equates to getting the wrong answer. Sometimes if it's just astronomy, they'll just say they're surprised, and that's fine. They'll move on from that.
That's why the ego is a blinding
yes.
agent. It blinds us because it's a tyrant.
Well, we watch what happens in 3 different ways. We've talked about this. For example, we've talked about these glitches. For example, in pulsars, we talked about anomalous redshifts, quasars in front of galaxies, and then of course we talked about the finger of God problem, where all the galaxies are sort of stretched out and pointing at the Earth. All of these are falsifications in and of themselves, but what they do is they take that and they put it over here and say, "This is an anomaly. You guys go just investigate that, but don't break the rules." And that's what they do.
Buddy, is that you?
It reminds me of Vsauce and Michael. And if you really watch his shows, you can tell that he just is enamored with anomalies and goes deep into them. Like nobody I've really seen tackle that kind of stuff. I love Vsauce.
He would be good to get on. Right?
Oh yeah, he does a good experiments, which basically are trying to end up showing showing, like you said, enigmas, common things. I too grew up with a book that was called The Reader's Digest: Mysteries of the Unexplained or something, which was a terrible title, but it was just basically a bunch of parts like disotraction humans and all.
Buddy, is that you? You got a live hot mic.
Yeah, I'm done. Sorry.
No problem.
Gotta watch that, man. It gets harsh.
Just mute it.
For
If you're
instance.
not talking. Just mute it. If you're talking.
Okay. All right. It's like the kid who can't, like, learn. That poor
I
kid.
hate that. It's like, yeah.
So sad.
I know.
Like,
I feel that way. I
zero-
feel that way myself, actually, a lot.
Zero aptitude. Like, sorry.
And then it's Groundhog Day every day.
Don't worry, they always get cut out. So, I mean,
Oh, I like that part. That was pretty funny.
I might keep that in. Who knows? We'll see what happens.
Yeah.
But yeah, but that's the nature of the humans right there with their they don't, because I mean they know exactly what you're saying, like when Heather or when you're talking about I think it was you, Heather, that was talking about their ego or their humanity and stuff, and they will so that they don't appear to be, oh well, I don't want to even talk about this ever again, I'm just going to ignore it. So they can't do that. They get a different reading, and it's entered into the scientific journal, so they have to control it, and so they'll send it off and get like a bunch of freshmen to go work on it or something, or get a small team over here, or they'll just basically consider it an enigma and no one will pick it up and work on it, and it will just get put there, and then people will only allow the answers, just like Egyptology, the answers that will fit into that theory, and you're not allowed to, because they won't allow that falsification to break their overall. They want the overall to remain separate, that the average man will only see the overall. They will not see all the problems behind the scenes. Or so it seems.
Is that how it should be?
No, of course not. We should be able to see it like we're doing here, where we go, I thought craters were made like this. Apparently I was wrong. This is how they were made.
Right, but it changes your entire perception of it changes the way you look at things fast, right?
Oh God, yes. But that's the acceptance of a paradigm. Until you,
you're entertaining that as a possibility. I mean, I would say there are craters that were formed from impact. I would say that's
there
true.
Probably has to
For
be.
sure.
Yeah, but this is to me just well, this is also how they're formed.
Oh yes, and put it
Right.
well. And this is what you just touched on, the big thing with the geology. The toolbox is not. It's not a problem. They just don't have enough tools in it yet to understand everything, and they're reaching in many ways.
Right.
And
Right.
and they're trying to make sense. The same thing as, like, what would you do if all you had was gravity inertia? Of course, the Big Bang theory, or not the Big Bang, the dark matter theory, when you come up with an error so monumental, like someone looked at a number and said, okay, I did a calculation of the light elements of the universe, guys. Okay, here is hydrogen, helium, and lithium. I put them all down here in 3 charts. These ones are off by this one. This much is off by this much. Wait. So these 2 are different than that one, off by a factor of 10 to the power of 107. Yes, my math is off by the factor of 10 to the power of 107, which is 107 zeros. That's how big of a mistake I made. And so because you can't have the amount of the light elements be wrong. They have to all match. All the theory is wrong. Basically, I don't want to explain it all to you. Go look it up sometime, but it's just called the theory of the light elements. Anyway, that right there is like saying, oh my God. And they just basically added in this mass, and they said it was non-baryonic because it's just like basically like antimatter. They're saying if this is matter that we can see and has mass, it's called baryonic matter. This stuff over here is non-baryonic matter. It's giving a name to a fictitious number and calling it real, and it's
declarative. It's declarative. Right?
Oh, it's
clearly
wholly unscientific, really.
But this is what it's become, and this is why it's so brittle.